All right, so if we're going to do trig of any angle, we have to find a way of figuring out what sine of 200 degrees is, minus the calculator. Actually, I should probably say 210 degrees. That would actually be easier. 210 degrees. That one we can find out exactly. So I just want to show you a method of finding them all. And it kind of goes back to the unit circle and which quadrants you're in. So we go back to the unit circle. And here's our unit circle. And then our bigger circle, whatever radius it is out here, or smaller. Doesn't have to be necessarily bigger. Could be within the blue circle rather than outside of it. And instead of having an angle in the first quadrant, let's push the angle into the second quadrant. So we're talking about theta. Now notice I drew theta right along the edge of the unit circle. Remember, the arc length of the unit circle, if it's a unit circle, is the same thing as the radian measurement. So this angle will be theta radians. It's bigger than pi over 2, but less than 2 pi. Now the coordinate of this point right here, of course, is going to be, x, y, cosine theta, sine theta. So now we're talking about possibly something like, what would be a good one? 90 plus 30, 120. Something like 120 degrees. What is the sine of x in that quadrant, though?
Negative.
It's negative. And the sine of, not sine, the function sine, as in plus or minus, yeah, of y? It's positive. Positive. So x is less than 0, negative, and y is greater than 0, positive. So when we find the coordinate of the unit circle, cosine is going to be negative in that quadrant, and sine is going to be positive. All right. We could do the same funky thing we did last class. Create a triangle here, a small one. Create a bigger triangle to the other circle at this point. And those two triangles would be similar. So I think the easy way to deal with this is this forms a triangle based on an obtuse angle to begin with. Now, if you know anything about right triangles, you can't have an obtuse acute angle inside of it. That's just contradictory. So this is just going to give us a way to figure out what coordinate we should use, and then we can go back to some old hippie caught another hippie tripping on acid. All right. So the base of the big blue triangle, if this point goes through, let's say, AB, the base of the big triangle would be A. Now, what kind of number is A?
It's a negative.
It's negative. So I highly suggest, let's make it explicit up here, it's negative A. I highly suggest when you draw your pictures, you put in negative A. It's not going to hurt anything. Don't think of it as a distance along the base of a triangle. Just think of it as the coordinate, x coordinate is negative in that instance. And the height of this triangle would be? B. So if I wanted to find on this triangle that has negative A here and a B there, and I'm trying to find this angle, what you're going to do is deal with the angle on the inside here. So what's the relationship between these two angles? Well, the way it's set up, they're supplementary, but that's not always the case. So what we call the relationship between these two angles is this one is the main angle that we're dealing with. This one in here, just this little baby one right here, is called a reference angle. Ooh, squeaky. That went away. Reference angle. So we're going to base our calculation on the reference angle, but then we can ignore a few things depending on how you do it. Now, the book doesn't put the negative A. If you don't put the negative on the A, you have to put negative in your answer based on the reference angle and what quadrant it's in. But I usually don't worry about things like that. Not right off the bat. So this would become the sine of theta, which is the big angle. This is going to equal the sine of the reference angle. I usually call it alpha, so we'll call this one alpha. Then the only thing that's different is possibly the sine. If it was cosine, it would be positive in that quadrant. No, it would be negative in that quadrant. Because it's sine, it would be positive in that quadrant. So far, so good? Kind of weird? I know it's a little strange. You have to kind of get used to it. Once I put numbers in there, it'll be a little bit easier. So this is going to depend on where you are. It'll be positive sometimes in 2 of the quadrants as you wrap around. It'll be negative sometimes in 2 of the quadrants as you wrap around. So reference angles are great. They give you the some old hippie caught another hippie tripping on acid ratios, but it doesn't necessarily give you the correct sign. Okay. For instance, the sine of 45 degrees, also known as the sine of pi over 4. Remember what that's equal to? Sorry, what sine of pi over 4 is equal to? Sine of 45 degrees off the top of your head? It's one you might want to memorize. If not, where would I find it?
Is it a half?
No, it's not a half.
Is it a third?
It's not a third. There is no third.
45 degrees, right?
45 degrees. So you come back to one of your special triangles. Which one has 45 degrees in it?
The second one.
The second one. If you're looking at 45 degrees, sine is opposite over hypotenuse. So what's opposite 45?
1.
1. What's hypotenuse?
Square root
The square root of 2. So this would equal 1 over square root of 2,
So
which I wouldn't mind you leaving, or
square root of 2 over 2.
square root of 2 over 2, which is more proper. There's reasons to leave it as 1 over square root of 2. There's other reasons to change it to square root of 2 over 2. All right, so if I look at the sine of, let's see here, 25. 225. I think that's the same as the sine of 5 pi over 4. Anybody want to check my work? How do you change degrees into radians? Little review word. How do you change degrees into radians? If I have 225 degrees,
180 degrees is 1 pi.
so
So
multiply by
Pi over 180.
pi over 180. Make sure those degrees are opposite of each other. One on the top, one on the bottom. So what's 225 over 180 reduced to? Thank God for calculators and fraction buttons, or no calculators.
yeah, I'm getting one.
If you get one of those, you have to do some fancy work. If you get one of those, it's 5 fours. So it would be 5 pi over 4. All right, so if I look at this one, 225 is in what quadrant? What quadrant? Location? Third quadrant? And if you want to think about it, this is pi over 4, so the top gets cut into 4 equal pieces, and you have to go 1 more. So it would be in the third quadrant. And what I'm going to draw is a triangle in the third quadrant. What's the reference angle? Just this little baby angle here. How much is that worth? If I go 4 pieces and I go 1 more, how far did I move? For that one little angle. Okay. 4 pieces. 1, 2, 3, and then 1 more. Pi over 4, pi over 4, pi over 4, pi over 4. Pi over 4. I mean, that's the beauty of using radians rather than degrees. If you had to do degrees, you'd have to go 225 minus 180 and come up with 45. But if it's radians, 5 pi over 4 is 1 more than pi, so you only went pi over 4. All right, and if we label the sides here, this side would be labeled -1, according to the special triangle. This side, since it's going down, is also going to get -1. And the hypotenuse gets square root of 2. So according to this reference angle, the sine is going to be opposite over hypotenuse. So it'd be -1 over square root of 2. So when we say this, it's equal to sine of pi over 4, the reference angle. In this case, it happens to be opposite of, because it's -1 over square root of 2, or negative square root of 2 over 2. So the way the book has you do it is they say write the 1 square root of 2 and come up with 1 over square root of 2, and then just realize because it's in the third quadrant, it's supposed to be negative. And there's a way of figuring it out. Some letters you can add to your picture over here. All students take calculus. All the trig functions are positive in the first quadrant. Only sine is positive in the second quadrant. Only tangent is positive in the third quadrant. Only cosine is positive in the fourth quadrant. So if we were going to do tangent here, remember tangent of 5 pi over 4 would be negative 1 over negative 1, opposite over adjacent, which turns into positive 1. So tangents are positive in that third quadrant. So you can either put the signs properly on the triangles. If it's going up, it's positive. If it's going down, it's negative. If it's going to the right, positive. If it's going to the left, negative. And then you don't have to worry about where they're positive and where they're negative. The answer will spit out right. Okay, how about tangent of 11 pi over 6. If you drew it, where would it go? 11 pi over 6. The bottom number tells you how many pieces the top gets cut up into. Nope. The bottom number is 6. So if you move from here to here, that's 6 pieces.
Yeah, fourth quadrant.
So if you go 6 more pieces, that's 12, right?
Yep.
And then if you back off 1, there's your reference angle, or reference triangle. Now when you draw these reference triangles, make sure you draw it towards the x-axis, not towards the y-axis. It's always towards the x-axis. So drop your altitudes perpendicular straight up and down. All right, now what's the reference angle? This angle in here. How much is this angle worth right here?
It's worth pi over 6.
It's worth pi over 6. If this one's pi over 6, which is equal to how many degrees? You haven't memorized that yet?
Is it 30?
It's 30. And therefore, this angle down here must be 60 pi over 3, which is 60. All right, so the triangle we need to look at is the 30, 60, 90. So you go back to your 30, 60, 90. If this is 30 degrees, what side is opposite 30 degrees? 1. But it's going down, so I'm going to label it negative 1. What side is opposite 60 degrees?
Square root of 3.
And because it's going to the right, I'm going to label it positive square root of 3. What's the hypotenuse then? 2. So if I'm looking for the tangent, I'm looking for tripping on acid. Opposite over adjacent. You're wondering what that phrase is, aren't you? So what's opposite in this case? Opposite of the reference angle is?
1. Negative 1.
Negative 1. And adjacent is?
That'd be square root.
Square root of 3. I was like 2. Square root of 3. Adjacent.
Yeah, adjacent.
You could also write this as negative square root of 3 over 3. And tangent in the fourth quadrant definitely is negative, according to our pretty picture over here. Everybody's got this written down so I can erase it.
I wrote it.
I also have to draw the triangles, just make sure we get the sides straight. So this idea of reference angles isn't really that hard. So how hard can I make it? No clue. See how hard the book makes it. They make it that hard. No, they don't do much difficult wise. How about cotangent of negative 2 pi over 3. The first thing you have to do is deal with location. You're going to get sick of drawing these pictures, but I hope guys you've drawn all of them. If you draw the picture, you won't make weird mistakes most of the time. If you try to do it in your head, generally you'll either get the sign wrong or the ratio wrong. One of the two. All right, so where's negative 2 pi over 3 located?
In second. No, maybe.
Negative 2 pi over 3.
Where would that be located? First of all, which way is the rotation?
It's gonna be
the opposite way, so
clockwise.
it would be
Clockwise.
In the fourth quadrant.
Fourth quadrant?
Third.
Third quadrant. Remember, the 3 in the
So
bottom
cut it
says
into 3, yeah.
take half of it and cut it into 3 pieces.
Yeah.
So you'd have, here's 1 piece, here's 2 pieces, and there's your third piece.
Yeah.
So if you go 2 of them, it would bring you
Oh.
over there. The 3 in the bottom tells you how many pieces to cut it into.
And the top number tells you.
How many pieces you have to go.
Okay. And
So-
because it's negative, you just go the opposite way.
Opposite direction, yeah. So if it was positive 2 pi over 3, you just go into the second quadrant. All right. So in this quadrant, you're going to draw a triangle. And this is going to become your reference angle. Well, take a guess what the reference angle is.
It is going to be 60.
Pi over 3. So each one of these triangles, or angle slices, is pi over 3. So what's left is pi over 3. Now if it was in radian measure, again, you'd have to subtract from 180 and all that other fun stuff. All right, so if that's pi over 3, what's this angle down here?
Pi over 6.
Pi over 6. Pi over 6 is equal to how many degrees?
30.
30. Pi over 3 obviously is 60. So when you label the sides, opposite the 30 is where you want to start with. You don't want to start with 60. So opposite the 30 is the smallest side. The smallest side is 1 for the 30, 60, 90 triangle. It's going to the left, so I'm going to label it negative 1. The side opposite 60 is the middle length side,
Square root.
and since it's going down, it's going to be
Negative.
negative. And the hypotenuse is going to be 2. So a 30, 60, 90 has 1, 2, square root of 3.
Why isn't the, if the triangle is going down, why isn't the hypotenuse negative like the other ones?
Remember, the hypotenuse is the radius of the circle.
It's always positive.
It's always positive.
'Cause
So
it
the
always
coordinates
seems
are the
like
only things that are changing. Now I'm not writing this negative square root of 3 as a length of a side.
Oh yeah.
I'm literally writing it as a coordinate. That way the sign just gets involved. And it's adjusted by using the radius as its denominator. Okay. So when I say what is this equal to, well it's equal to, what's cotangent? Cotangent?
I don't think we went over
Yes
this.
we did.
Oh, it's just opposite of tangent, isn't it?
Reciprocal. Don't say opposite. Reciprocal. Opposite means to change the sign. So what's the reciprocal of tangent? Well, tangent is opposite over adjacent, and this one is going to be
Adjacent over opposite.
adjacent over opposite. And the adjacent side is of pi over 3 here.
Adjacent is negative 1
It's negative 1, the one touching it, but not a right angle.
over negative square root of
And the opposite side would be negative square root of 3. So the final answer, 1 over square root of 3, or
3.
square root of 3 over 3. Huh. Same answer as this one over here. Interesting.
Not the same thing. This is sort of. It's just that one's negative.
Well, I mean, ratio-wise, kind of cool. Oh, but remember cofunctions? You weren't here for that. Cofunctions. They're off by 90 degrees. And 30 and 60 are off by, well, they're complementary. So their cofunctions will be equal, except for a sign in that case. Location is different. How much harder? Seriously, that's as hard as I can make it. Ooh, there's these type questions I have to be careful of. Simple question. Yeah. I read this. Starts at the origin and goes through 4, -7. Find sine, cosine, tangent of the angle formed. I'll hear you anyways. It's a back. It's on the side. So, what should I do first?
Draw a picture.
Draw a picture. So, coordinate system. Where's my angle going?
Where is it going? It's going to be in the fourth quadrant.
Fourth quadrant. So it starts here, 4, -7, someplace down here it's going through. Now your choice. Your angle could wrap all the way around to it, or it could just drop down to it. Either one works perfectly fine. Either way, you really don't care. Let's just call it the reference angle theta. How would I label my sides? The top portion of the triangle would be measuring,
It would be 4.
it would be 4. The side portion over here,
So,
but you really want to label it
Negative
-7 to get the sign involved. How do I find the third side?
Diagram.
So c squared equals a squared plus b squared. C in this case,
It's going to be the hypotenuse.
what you're looking for. So c squared equals a,
It's going to be 4
squared. So 16 plus
49.
49 for 7 squared. That's 50, 60.
It's 65.
Alright, so c squared equals 65. And c is going to equal the square root of 65. Does that break down?
Yes, it does.
Does
I
it?
think so.
no.
5 and 13, isn't it?
Mhm.
Yeah, so that doesn't break down. Alright, so this side is the radius, so it's going to be this positive square root of 65. You're never going to get a negative for that one. And how do I find sine of that angle?
Sine is
Some old hippie. Opposite of that reference angle,
-7.
-7. Hypotenuse,
Square root of 65.
square root of 65. There's not much to trig, it's actually kind of easy. What about cosine of that angle? Well, that's some old hippie caught another hippie. So adjacent of that triangle, so one touching the angle is 4
Over square root of 65.
over square root of 65. And then tangent of theta,
It's -7 over 4.
is tripping on acid, so it would be opposite over adjacent, which is also sine over cosine. Sine divided by cosine. Alright, let's make it worse.
So tangent is always sine divided by cosine.
You can do that substitution. Tangent can also be represented as sine over cosine.
So
Just like
if we-
cosecant can be represented as 1 over sine.
So if we put the answers from sine and cosine into a fraction, and it would come out to what the tangent would be.
Yeah, I mean, look at it. If you take -7 over the square root of 65 and divide by 4 over the square root of 65, what's eventually going to go away?
The square root of 65.
You're left with -7 over 4. But that's the hard way of doing it. It's much easier just to go get the tangent. All right, let's make it a little bit trickier. Given that cosecant, oh, dang it, can't be -2 over 3. -3 over 2. There's a reason. -3 over 2. Given cosecant is negative 3 over 2 and cosine is greater than 0, find sine, cosine, and tangent. Great. Now what?
You draw a picture.
I'll start.
Pictures make everything better.
If anything, that's your first thing.
You
Draw a
always
nice little
take
picture.
a picture first.
Yeah, draw a picture first. And usually coordinate axis. Okay, now what? The question always becomes location. So how do I find the location of theta? See, 4, negative 7 is nice. You can plot it and you know exactly where it is.
Yeah.
This isn't as nice. So it gives you two pieces of information.
That
The cosecant is
Sine.
negative and the cosine is
positive.
positive. So all you have to do is find the quadrant where cosine is positive and cosecant is negative. Now remember, it goes all students take calculus. So cosine being positive, the only two places it can happen is the first quadrant and the fourth. So that angle has to either be in the first quadrant or the fourth.
It's gonna be
4.
It has to be in the fourth because cosecant is the same thing as,
sine.
well, the reciprocal of sine, and it would be negative. And the only quadrant sine is negative in is the third and the fourth. So it only overlaps in the fourth quadrant. So when you draw your triangle, you're going to put it in the fourth quadrant. Now when I put theta in here, that's kind of lying. It's actually the reference angle of theta. I don't know exactly where theta is. It could be wrapping around this way or rotating a few thousand times and then stopping there. So when I put theta in here, I'm really talking about the reference angle. But I take care of it by putting the signs in my picture. So if this is cosecant is equal to negative 3 over 2, cosecant theta is equal to negative 3 over 2, what does the negative 3 represent? What does the 2 represent?
The 2 is actually the x, I believe.
Don't think of it as x and y. I would rather you think of it as opposite adjacent hypotenuse.
Good adjacent.
The negative 3 would be the hypotenuse, wouldn't it?
Well, the hypotenuses can't be negative, so 3.
Okay.
I'll give you that. What's the 2 represent then? 3. I'll put 3 here.
The opposite side?
The opposite side. Because remember, this is the reciprocal of
Sine.
sine, and sine is some old hippie. So this will be hypotenuse over opposite. But because the hypotenuse can't be negative, the 2 is going to get the negative. So that's hypotenuse, and then opposite would be over here, so negative 2. And it matches too, because it's going down. What's the third side? Well, I gotta find it.
Well, it's greater than 0, isn't it?
Well, yeah. But, you know, c squared equals a squared plus b squared. Do I know c in this case?
Yes.
Yeah. It's 3, so this will be 9. A,
We don't need it.
we don't know it or we do know it, doesn't matter. B,
It's gonna-
we're kind of forced to know it, it's 4. 2 squared.
so-
Well, negative 2 squared.
So it's square root of 5.
Square root of 5. So a is going to be the square root of 5. Plus or minus. Now that depends on where it is in the picture.
Positive.
It's positive because it's going to the right, so square root of 5. And then the rest of it's kind of easy. The sine of this angle, therefore, is going to equal
Negative
opposite over hypotenuse, which is negative 2 over 3, which is the reciprocal of cosecant, directly. All right, cosine of theta is going to equal adjacent over hypotenuse,
So square
caught
root
it
of
like a bee, which is what?
Square root of 5.
Adjacent is square root of 5 over 3. And then tangent of theta is going to equal
Negative 2 over square root of 5.
opposite over adjacent, negative 2 over
Square root of 5.
square roots of 5. Some old hippie cognitive or hippie trick gonna always come back to that eventually. Not that bad, right? So location sometimes could be direct, but other times you have to kind of figure out where the heck it is.